Greetings, it is Maxo Diddley here, and today I am here with another Java tutorial to help you get an A in your coursework or exam. And today we're here with how to compress a file containing text using Java. So what I mean by this is, if you have a file that contains text, we're going to be able to compress that file. This compression is not going to work on things like video, images, audio, and other things. Purely things with text. So let's get right into how we do it. And also, if you want to know how to decompress a file, click the I up in the corner, as that's going to be the partner for this tutorial. Because we're going to cover compression in this one, and then decompression in the other one. So let's get right into it. Firstly, be sure to import java.io.file, file input stream, file output stream, java.util.zip, deflater output stream, and java.util.zip inflator output stream. And the type of compression we'll be doing is going to be part of the java.util.zip library, and it's based off the popular zlib compression library, which was initially developed as part of the PNG graphics standard, and it's not protected by patents. And let's get into how we do it. So we've got a string name, a string file name called data, and string file extension .txt. There are better ways to separate these two, and you'll see why we do it in a moment, but I'm using different strings as this is a compression tutorial, not a string manipulation tutorial. Then we do system.println, compress file, file name and file extension. We're going to print out whether or not the file was compressed or not. So let's get into defining that method. It's a public static boolean, compress file, string extension. Public static boolean, so it's going to return a true or false. Compress files the name. String file is going to be the name of the file without the extension, and then string extension is the extension, like .txt or .csv or whatever you want it to be. First thing we're going to do is we're going to do a bit of housekeeping. String file path equals file plus extension. This is going to be the original file that we're going to compress. And string comp file path equals file plus compressed plus extension. You can customize this, but the compressed file will be a combination of file, compressed, and then the extension. So if it was data.txt, it would be datacompressed.txt. Then we're going to do a try catch statement. So we're going to leave the try empty for a moment, and in the catch you do exception E, then you do system.println E and return false. If an error occurs, the file was not compressed, therefore we need to print out the error message to inform the user and then return false because the file wasn't compressed. The next thing we're going to do is we're going to do file input stream, file read equals new file input stream file path, file output stream, file write equals new file output stream, comp file path, and then deflater output stream, comp equals new deflater output stream file write. So basically, we are creating a file input stream. This is how we're going to read data from the original file. Then we're going to make a file output stream, which would be responsible to writing data to the file which will contain the compressed data. But we're going to make a deflater output stream. It's going to be called comp, short for compression, equals new deflater output stream, and we pass in the file writer, or the file output stream object we just made, and so our deflater output stream is going to write a compressed version of our data to a file. So we set up the objects to do the file interaction. Just to clarify, this is responsible for reading data from the original file. These two are responsible for writing compressed data to the compressed file. Then we do int data, and then we do while data equals file reads.read, not equal to -1, we do comp.write data. Basically, what we're going to do is we're going to assign the values on the line to this data variable, and then we're going to do a while there's a line to read in the file, write that line to the compressed file, and we compress the data at the same time using comp.write data, which is referencing this variable, which is just going to store the current line we're reading. If it's equal to -1, that means there's nothing left, therefore we stop the while loop. So literally this is just going to read a line, then write that to our compressed file, and do that for every line in the file. And that's kind of it for compressing the data, but there's a bit more we're going to do. So basically, what happens if the compression doesn't make the file smaller, or what if it makes the file bigger? Surely then we don't want it. And that's exactly what we're going to do. So if you don't want any more, you can stop. But if you want more, carry on. What we are going to do now is we're going to do long original size equals new file filepath.length, and we're going to store this as a long just in case the byte count is gigantic and goes over the integer length in Java. So that's why we're doing long. So we do long original size equals new file filepath.length. So we have to create a new file object with this file path, and then we can do .length to get the length, and we do this for the compressed file we have as well. And then we're going to print out the size in bytes of these two files to illustrate the point to you. After that, we're going to do if original size is greater than comp size. Basically, if the original size of the file is greater than the compressed size, that means the compression worked. The file is smaller, so we return a true. Otherwise, let's say the original size is equal to the comp size, or the original size is actually less than the comp size, that means compression didn't occur. What I mean by that is, the deflater inflated the file size. I'm sorry, that was awful. But basically that means there was no compression, therefore we don't actually want this file. So what we can do is we can do file to delete equals new file comp file path. This is the file path of the compressed, in quotes, file. And then we just delete it, and then we do a system.println saying can't compress the file, and we return a false to imply no compression occurred. You don't have to do this, you can just return a false, but I advise we do something to make it more convenient for the user. You don't have to though, it's optional. And that's basically it. Also, be sure to put a return true if you choose not to do all of this underneath comp.close. So we're going to scroll up, and we're going to look at what we've got here. We're going to compress data.txt, and then print out if it compressed or not. So let's do it. But firstly, so if you're on NetBeans and want to know where your project is, go to Projects, and then find your project, right-click on Properties, and then you'll see the file path, copy and paste that into your File Explorer, and then you'll go to your Java project location. So we're going to have our files relative to the Java project, implying that they're right where the Java project is. You can add subfolders, put them on your desktop, whatever you want, but this is how you can get to your file. This is where I'm having the files for this tutorial, and I showed you how you can get to here if you're using NetBeans. It's going to be different for different IDEs, but if you know where your project is, you can just put your files here and then follow along. But firstly, this is data.txt, a bunch of characters. And now I'm going to show you a compression, so save your work and hit play. And it says original file size was 6,198 bytes, and the new file size is 243 bytes. And then it says true because we compressed the file successfully. If we go back here, we see data.compressed. Instantly you can notice a difference here in the size here. It's a bit rounded, by the way. If we click on data compressed, you got a bunch of nonsense, but don't worry. In the next tutorial, I'm going to be showing you how we can decompress this back into the beauty that is keyboard spam. But before we do that, I just want to show you what happens if we do a file that is empty. So, this is an empty file. You can't compress this because it doesn't have any data. But let's press play. And it says original file size 0 and the new file size is 8. This is weird. This implies the compression took up 8 bytes and the original was 0. Therefore we can't compress the file, which is true. You can't go below 0 bytes of storage, and so there's no point compressing it, so it deleted the file. Well, the compressed version, which isn't there anymore. So that's it for this tutorial. Be sure to leave a like and a comment if you enjoyed. And if you want to see more compression tutorials, like telling you how we can change the severity or level of the compression, or how to compress different data types, subscribe. Thanks for being a great audience. I'll see you next time.